Due to the increasing number of turbocharged vehicles on the road these days, the automotive technician needs to be aware of what causes faults within these systems. This diagnosis refers to OEM systems and may not apply to aftermarket turbocharging. The position of the turbocharger wastegate valve is generally controlled by the engine control module, or ECM. The ECM uses a turbocharger control solenoid and a boost pressure sensor to control the turbocharger wastegate. The ECM uses PWM on the control circuit to activate the solenoid valve. The turbocharger pressure sensor responds to pressure changes in the intake manifold. The pressure changes occur based on engine load and turbocharger boost. The engine control module supplies 5 volts and a low reference to the turbocharger pressure sensor. The turbocharger pressure sensor provides a signal to the ECM, which is relative to the pressure changes in the manifold. Underboost ETCs will be logged when the ECM determines that the actual boost pressure is lower than the desired range for a predetermined time. The check engine light will be illuminated, and the ECM may command a low power or limp mode for engine protection. We need to look for any reason the ECM cannot control boost pressure to its specified limits. Non-OEM wheels, exhaust systems, modified intake systems, and piggyback controllers may cause these faults. When diagnosing, check for the presence of any aftermarket equipment. It may be necessary to check the vehicle's freeze frame data to help reproduce the conditions at the time of the fault. With the engine running, hold the engine speed to around 2000 RPM. Command the turbocharger wastegate open, then closed. Observe the boost pressure sensor data and verify the sensor parameter changes with the scan tool commands. If the boost pressure data does not change in relation to scan tool commands, it will be necessary to perform a visual inspection of the system. Inspect the boost pressure sensor for damage, blockages, or a leaking seal. Check the harness connector for security. Inspect the intake system for any obstruction, split or collapsed hoses. Inspect the intercooler for leaks. On the turbocharger, check for seized or binding linkages, damaged or leaking vacuum and pressure hoses. Inspect the compressor wheel and housing for any damage. Pay close attention to the turbine shaft. If this is hard to rotate, boost pressure will be affected. If a shaft seizure or fault is found here, it will be necessary to check the engine oil pressure, supply and return. Inspect the exhaust system for any blockages downstream or leaks upstream from the turbine. Inspect the wastegate solenoid valve for leaks or damage. Inspect the mechanical operation of the solenoid valve. This can be done with a hand-operated vacuum pump and a scan tool. Apply vacuum to one side of the solenoid. The valve should hold vacuum until commanded with a scan tool. When activated, you should be able to hear the solenoid operating and see the vacuum decreasing. Underboost codes on a wastegate turbocharger may be caused by a faulty solenoid or solenoid-controlled circuit. We need to determine if the wastegate solenoid valve is receiving commands from the ECM before condemning this component. Let's test the electrical circuit now. Turn on the ignition. With the meter set on volts and one lead connected to ground, back probe each terminal of the solenoid. Battery voltage should be evident on each terminal. This indicates a correctly operating supply circuit and a voltage path through the solenoid. A short to ground on a wastegate turbocharger system may cause these codes. This ECM controls the wastegate control solenoid via pulse width modulation of the low side circuit. This test is best performed with an oscilloscope and scan tool used together. Back probe the low side terminal of the control solenoid with one channel of the scope. Using a scan tool, activate the wastegate control solenoid. You should see a square wave pattern that reflects the scan tool command. A steady battery voltage signal may indicate an open circuit or short to voltage on the low side path. If you don't have an oscilloscope, then this test may be carried out using a multimeter. With the meter set on duty cycle, connect 1 meter lead to battery positive and back probe the control solenoid low side circuit with the other. Using a scan tool, command the wastegate control solenoid to maximum and back to minimum. The meter should reflect the scan tool command. To test for a short to ground, connect the meter, set on volts, between battery positive and the control terminal in the solenoid harness connector. The meter should display 0 volts. If there is any reading other than this, disconnect the ECM while monitoring the meter. If the meter still displayed a voltage reading with the ECM disconnected, then the short to ground is in the harness. If the meter displayed 0 volts with the ECM disconnected, then the short to ground is in the ECM or a circuit from the ECM. To isolate the short to ground, test for continuity between the solenoid control circuit terminal and every other terminal in the ECM. If the meter displays an open circuit here, then the fault is in the ECM. Once repaired, perform the drive cycle for that DTC and recheck for fault codes. Always test and confirm your diagnosis before replacing any parts. Remember, a well-trained technician is a skilled technician. Thanks for watching.